Let's prove using Lagrange mean value theorem that sine inverse of 3 by 5 lie between pi by 6 plus 1 by 5 root 3 and pi by 6 plus 1 by 8. Let's recall what Lagrange mean value theorem says. Lagrange mean value theorem states that if a function f is continuous on the closed interval a comma b and differentiable on the open interval a comma b, then there exists a constant c such that f dash c equal to fb minus fa divided by b minus a, and that constant lie between a and b. So we want a function f, and then we want an interval on which that function is defined. Once again, we want to prove that sine inverse of 3 by 5 lie between pi by 6 plus 1 by 5 root 3 and pi by 6 plus 1 by 8. That is same as saying sine inverse of 3 by 5 minus pi by 6 lie between pi by 6 plus 5 by pi by 6 plus 1 by 5 root 3 minus pi by 6 and pi by 6 plus 1 by 8 minus pi by 6. What we are doing is we are subtracting pi by 6 throughout, and pi by 6 gets cancelled and pi by 6 gets cancelled. Now these two are equivalent because from the second expression we can add pi by 6 and get the first one. Once again, these two are equivalent. But observe that pi by 6 can be written as that's 30 degree and sine 30 degree is half. So sine inverse of half. Remember, we want f dash c equal to fb minus fa divided by b minus a. So we can get something like f of b minus f of a. So we define fx equal to sine inverse of x on the closed interval half comma 3 by 5. So we got the closed interval a comma b. A turns out to be half and b turns out to be 3 by 5, and we get something like fb minus fa as well if I take fx equal to sine inverse of x. Is this function continuous? If we want to apply Lagrange mean value theorem, the function must be continuous on the closed interval. Then fx equal to sine inverse of x is continuous. This is continuous on closed interval half comma 3 by 5 comma differentiable on the open interval half comma 3 by 5. How can we say so? We can say so because we know that derivative of sine inverse of x is 1 by root over 1 minus x square, and that is defined in the open interval minus 1 comma 1. So yes, sine inverse of x is continuous, not just continuous, in fact it is differentiable in the closed interval as well, and not just in the closed interval but in fact in the interval minus 1 comma 1, which is much bigger than this interval. So we got it continuous on the closed interval, f is continuous on the closed interval, f is differentiable on the open interval. Then by Lagrange mean value theorem there exists a constant c such that f dash c equal to fb minus fa by b minus a. So by LMVT, in short, that stands for Lagrange mean value theorem, there exists a constant, that's a real number, c in the open interval half comma 3 by 5 such that f dash c equal to f of b. F of b is sine inverse of 3 by 5. Sine inverse of 3 by 5 minus f of a, that is sine inverse of half. Sine inverse of half fb minus f of a divided by b minus a, that is 3 by 5 minus half. As we said earlier, fx equal to sine inverse of x is differentiable. Fx equal to sine inverse of x is differentiable, and f dash x equal to d dx of sine inverse of x equal to 1 by root over 1 minus x square. That is true for every real number x that lie between minus 1 and 1. And in this case, we are just considering the real number lying between half and 3 by 5. So, f dash of c equal to 1 by root over 1 minus c square must be equal to sine inverse of 3 by 5 minus sine inverse of half is just pi by 6 divided by 3 by 5 minus half, that is 0.6 minus 0.5, that's 0.1, that is 1 by 10. If we take LCM, 3 times 2 is 6, 6 minus 5 is 1, so 1 by 10 anyway, equal to 3 sine inverse of 3 by 5 minus pi by 6 by 1 by 10. Let's take 1 by 10 to the left hand side to say that 1 by 10 of 1 by root over 1 minus c square equal to sine inverse of 3 by 5 minus pi by 6. Okay. Now we want some kind of inequality. We know that constant c, comma, c is greater than half and less than 3 by 5. C lie on this open interval half comma 3 by 5. So c is greater than half, less than 3 by 5. But we want c square, rather 1 by square root of 1 minus c square. So c square is greater than half square and less than 3 by 5 square. Once again, c square is greater than half square and less than 3 by 5 square. That is, half square is 1 by 4 is less than c square is less than 9 by 25. Now we want 1 minus c square. Let's take negative throughout. When we take negative, inequality reverses in the sign. So we get minus, 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 and less than gets replaced by greater. Less than gets replaced by greater. 1 by 4 we copy as it is. What we did, we changed the sign and we did reverse the inequality. Okay, now let's add 1 throughout. So we got the inequality. Minus 1/4 is greater than minus c square, which is greater than minus 9 by 25. But we want 1 minus c square, so we add 1 plus 1 plus 1 plus 1. And we simplify. 4 minus 1 is 3. So 3 by 4 is greater than 1 minus c square is greater than 25 minus 9 is 16 by 25. And we need to take square root as well. Once again, 3 by 4 is greater than 1 minus c square. That's greater than 16 by 25. And we take square root. Square root of 3 by 4 is greater than square root of 1 minus c square. and that is greater than square root of 16 by 25. That gives us root 3 by 2 is greater than root over 1 minus c square, and that is greater than 4 by 5. But we want reciprocal as well, right? We got 1/10 of 1 by root over 1 minus c square. Let's take reciprocal to obtain 2 by root 3, 5 by 4, and then 1 by root over 1 minus c square. But as we said earlier, if we take the reciprocal, the inequality reverses. When we took the negative, the inequality reverses, and when we take the reciprocal, then also inequality reverses. Lastly, let's do 1/10 as well. So we got 2 by root 3 is less than 1 by root over 1 minus c square is less than 5 by 4, and we multiply by 1 by 10. 1 by 10, 1 by 10, 1 by 10. Oh, we can cancel by 2. 2 times 5 is 10. We can cancel by 5, and we get 1 by 2. And this expression 1 by 10 of 1 by root over 1 minus c square is simply equal to sine inverse of 3 by 5 minus pi by 6. By 1 by equality 1. Equality 1. 1 by 5 root 3 is less than sine inverse of 3 by 5 minus pi by 6, and that is less than 1 by 8. Now we should add pi by 6 throughout to obtain 1 by 5 root 3 plus pi by 6 is less than sine inverse of 3 by 5 minus pi by 6 plus pi by 6, which is less than 1 by 8 plus pi by 6. Minus plus gets cancelled, and we are done.